Apportionment. So what is this concept of apportionment? What's this whole idea? Well, basically, it is a process that exists to fairly assign identical indivisible objects among individuals entitled to shares that may be unequal. So a lot of times when we're thinking about, we may have a number of representatives or a number of seats, for example, like in Congress. How are we going to determine how many seats each state is going to be allotted? We want to try to determine it based off of the size. So for example, in Congress, there's 100 senators that make up Congress with 50 states, so it's equal division. It's 100 divided by 50, so there are 2 senators that represent each state regardless of the state's size. Whereas in the House of Reps, it's based on the population of the state. So we want to determine what should be the number of seats that each state would get if they were varying sizes. So there's a couple of different methods that you can utilize to go and find these correct number of seats. But we're going to concentrate on 3 different methods called Hamilton, Jefferson, and Webster. And they're a little weird and they're very similar in their own ways. And then there's some little things that make them very different. And you'll see that as we go through the process. So the very first vocab word that you want to know is the Standard Divisor. The Standard Divisor. I'm going to notate that as SD for the remainder of this video, but please remember it stands for Standard Divisor. It is equal to the total population or the total amount that you have, and you divide that by the number of items that you are concerned with. So maybe you're talking about the seats, so you'll divide it by the number of seats. Maybe you're talking about the number of positions for an elected position, so that would go at the denominator. Maybe you're talking about the number of instructors to teach a course, so that would go at the bottom. Whatever it is that you are concerned with, that is the value that's going to go at the bottom, okay? All right, so we're going to do an example together. And in this example, I'm going to have districts and their respective population. And we're going to have District 1, we're going to have District 2, we're going to have District 3, we're going to have District 4, and then we're going to have District 5. And let's say that District 1 has 32 people, District 2 has 80, District 3 has 41, District 4 has 67, District 5 has 20. So just so you know, that creates a total of 240. And let's pretend that we have 20 seats that need to be allocated. Okay, so again, I'm going to begin by going through and deciding what method do I want to utilize. So we're going to begin with Hamilton. Now I'm not going to write all of the steps, but I'm going to clearly state the steps so that hopefully it will be very easy for you to be able to make steps if that's easier for you, okay? So step 1 is going to be to find the standard divisor. So in order to do step 1, to find the standard divisor, I'm going to take the total population, which in this case is 240, and I'm going to divide it by the number of items that I have. Well, in this case, we're talking seats, and we have 20 of them. So we're going to do 240 divided by 20, and that gives us a standard divisor value of 12. Okay? Step 2. After we have our standard divisor, we are going to look for something called our standard quota. Our standard quota. The way that I'm going to do that is I'm going to take each district. So for example, District 1 has a total population of 32. And I'm going to divide it by the amount that I found as my standard divisor. That value is 12. And 32 divided by 12 gets me 2.67. And again, I'm going to call this column here, these are my standard quota, my quotas. Okay? And I'm going to do this for every district. So District 2 is going to be 80 over 12, and that's going to give me 6.67. District 3 is going to be 41 over 12, and so that's going to give me 3.42. District 4 is 67 over 12, and that's going to give me 5.58. And then District 5 is 20 over 12, which is going to give me 1.67. So now I have identified all of my standard quotas for each respective district. Now these standard quota values that I've written down, I'm now going to look at them and I'm going to write down what is called their initial values. I'm going to do this in purple. When I write down their initial values, I am going to not round. No rounding. So, I'm not following the rules of math, but instead I am focused on that whole number value 2, 6, 3, 5, 1. And I'm now going to total up those initial values. So 2 plus 6 is 8, plus 3 is 11, plus 5 plus 1 brings me to 17. Now, you're going to compare the number of seats that you have based off of your initial values, which is 17. And you're going to compare that to how many you are trying to allocate for, which is 20. And you're going to look at the difference. There is a difference of 3. I still have 3 seats that I need to assign to specific districts. The way I'm going to determine that, I'm going to do this in my little maroon color here, is I'm going to begin looking at the fractional portions. So I'm underlining all the values after the decimal because those are fractional values. And I'm going to look for who has the largest numbers. I need 3. So the top 3 largest values. So it just so happens that they're equivalent, 6, 7, 6, 7, and 6, 7, and there are 3 of them. So what Hamilton's method says is I'm going to give those extra seats to the districts that have the largest fractional value. So I'm going to add a seat to District 1. I'm going to add a seat to District 2. I'm going to add a seat to District 5. And so now I'm going to create my allocated seats based off of Hamilton's method, so my final numbers. And District 1 will get 2 plus 1 is 3. District 2 will get 6 plus 1 is 7. District 3 will get 3. District 4 will get 5. And District 5 will get 1 plus 1, which is 2. And sure enough, when I total those values together, it equals 20, which is the value that I am looking for.